So for these, I'm supposed to evaluate the following limits. So if I'm looking at these as x goes to 0, the denominator is going to 1. 0 squared plus 1 is 1. Cosine of 0 is 1. So this one is actually continuous at 0. I don't have any issues. So this is actually going to cosine 0 over 0 squared plus 1, which is going to 1 over 1, which is 1. The next one, as x goes to infinity, the bottom's going to infinity and the top's going to infinity, so I can take I can apply L'Hopital's rule. So this is an indeterminate form of type infinity over infinity. So I can apply L'Hopital. So that gives me the limit as x goes to infinity of derivative of natural log x is 1 over x. And then the derivative of square root of x is 1/2 x to the negative 1/2. And so let's spend a little bit of time working on this. So that's the limit as x goes to infinity of, this will end up being that 1 over x, the x can go down. The 1/2 on bottom can turn into a 2 on top. X to the negative 1/2 would be x to the 1/2 here. So this is going to be the limit as x goes to infinity. I can cancel one of those x to the 1/2, and I'm left with 2x to the negative 1/2. And so as x goes to infinity, well, let's see. I could do limit as x goes to infinity. Let me write it this way. 2 over square root of x. So as x goes to infinity, this whole thing is going to 0. Next, I want to compute the following derivative. Okay. So d prime. So overall, this is going to be a quotient rule. But when I take the derivative of the top, I'm going to use product rule. So let's do quotient rule. So low d high minus high d low, derivative of tangent is secant squared, divided by low squared. So the derivative of the top, I'm going to have to use product rule. So I'll have 1 times e to the x plus x times derivative of e to the x is e to the x. And so that will work for that one. Let f of x equal pi times x squared, pi to the x squared. So f prime of x will be pi to the x, sorry. Oh. Somehow I can't erase. Okay, I'll scribble that out. This will be pi to the x squared times the natural log of pi. So what I'm applying here is this derivative rule. This derivative rule. And then in collaboration with the chain rule. So now I'm going to do times the derivative of this inside part, which will be 2x. So that is the first derivative. And then the second derivative, I'll have to do, okay, so I have a product rule, so I have this times that. So we'll do the derivative of the first, which will be pi to the x squared times the natural log of pi times the natural log of pi times 2x plus, now I'm going to leave the first part alone. Times the derivative of 2x, which is just 2. And so I can leave it just like that. The next one says, in chemistry, pH is a scale used to measure the acidity of a solution. The pH of a solution is defined by that equation. Compute the instantaneous rate of change of pH with respect to the hydrogen ion when the pH is 2. Okay, So what I need to do is take the derivative of log base 10. So I kind of forgot how to do that. So I could use change of base. So log base 10 of x is equal to natural log x over natural log of 10 by the change of base formula. And I do know the derivative of natural log x. So I can get that my pH is equal to the negative of natural log x over natural log 10. And if I take the derivative of pH and evaluate that at 2, oh well, let's take the derivative first and then I'll evaluate. So that's going to be negative 1 over x times 1 over natural log 10. And if I plug in 2 into that, I'll have negative 1 over 2 times 1 over natural log 10, which is approximately, when I plug that into my calculator, negative 0.2174. Okay, and then what would be the units of that? Okay, pH is the acidity. Let's see. So this is going to be a change in pH over a change in time, or let's see. Change in pH over change in, let's see, X is measured in the concentration of hydrogen atoms. So this will be, okay, so pH is measured in what units? I'm not sure what units pH is measured in. So this is going to be pH units per independent variable units, which will be concentration of hydrogen. This one says the amount of medication in a person's bloodstream changes at a rate of that. So I'm given a rate of change. T hours after injecting 500 milligrams. Okay. What is the amount of medication in the person's bloodstream? 3 hours after taking an initial dose. Okay, so what I want to do is I want to add up the total amount of changes from 0 to 3. Okay, so I want to add that up. So to do this, I'm going to need to do a U substitution. I'll let U be negative 1.4 T. Then du is going to be negative 1.4 dt. And so to change this, I'll need a negative 1.4. So I'll have 1 over 1.4. I can also pull the 700 out. 0 to 3, e to the negative 1.4 t times negative 1.4 dt. Okay, so what I did was I just pulled the 700 out. I divided by 1.4 and multiplied by 1.4 so that I could have that 1.4 dt sitting there for my du. Okay, and so this is equal to 700 over 1.4, and I want to integrate from, okay, when t is 0, my u is 0. When t is 3, my u is 1.4 times 3, which is 4.2. Oh, sorry, negative 4.2. E to the u du. And so if I integrate that, I get evaluated from 0 to negative 4.2. So that gives me 700 over 1.4 e to the negative 4.2 minus e to the 0. And remember, e to the 0 is 1, So we are going to have to write that e to the 0 here. So you can compute that into your calculator. Hang on. So I got negative 492.5 milligrams. Okay, so that, hang on. What does the negative 492 mean? That means that's the, okay, so the question is, so this is equal to negative 492.5. Okay, so the question is, what is the amount of medication in the person's bloodstream? Okay, so they started with 500 milligrams, and they have lost 492.5 milligrams. And so I think what's left over is 7.5 milligrams is what's left in the bloodstream. What is the amount of medication in the bloodstream 3 hours after taking a dose? Okay, so that's that. Next, I'm asked to find dy dx for this curve. So let's take the derivative implicitly with respect to x. 2x minus the derivative of sine of y is going to be cosine of y dy dx equals derivative of xy squared. I'm going to use product rule, so I'll have 1 times y squared plus x times 2y dy dx plus pi squared, derivative of that is 0. Now I can solve that for dy dx. So I'm going to add and subtract the terms that do not have dy dx in them to one side and move everything else to the other side. So I'll have 2x minus y squared is equal to 2xy dy dx plus cosine y dy dx. Now I can factor out the dy dx and divide over what's left. Let's do this. And so I get dy dx is equal to 2x minus y squared divided by 2xy cosine y. Oh, plus cosine y. And if I evaluate that at the point x equal pi, y equals 0, that gives me 2 pi minus 0 squared over 2 times pi times 0 plus cosine of 0, which gives me 2 pi over 0 plus 1. So the final answer is 2 pi. This one says car A is 30 miles north of car B at 1 p.m. Car A drives west at a speed of 55 miles per hour, and car B drives west at a speed of 75 miles per hour. How fast is the distance between car A and car B changing at 3 p.m.? Okay, so we have car A and car B, 30 miles in the north direction, okay. Car A drives west at a speed of 50 miles per hour. So there's car A driving off. And we'll call this maybe little a. And car B drives west at 75 miles per hour. So car B is going a little faster. How fast is the distance between car A and B changing at 3 p.m.? So this distance between car A and B, well, I could draw a right triangle here and figure that out. So this distance here, from here to here, would be little b minus little a. And then this would be 30, and this will be, we'll call C. Okay, and so I know that dA dt is equal to 55, and I know that dB dt is equal to 75 miles per hour. And so I'm interested in dC dt. When they've been going for 2 hours, so that's when A is equal to 55 times 2, and B is equal to 75 times 2, which is 150. Okay, so let's find a relationship between A, B, and C. So I know that C squared is equal to 30 squared plus B minus A squared. And so that's my relationship between A, B, and C. Then I can take the derivative of that implicitly with respect to t. So I'll get 2c dc dt equals, the derivative of 30 squared is 0. I'll get 2 times b minus a to the first times dB dt minus dA dt by chain rule. And so then I can plug in everything I know to solve for dC dt. So if I know A is 110 and B is 150, I can find C. So C is equal to the square root of 2,500, which is just 50. So I'll have 2 times 50 dC dt equals 2 times 150 minus 110. dB dt I know is 75. dA dt is 55. So I could just solve that for dC dt. So I get 16.
I love it. Hey, Dr. Mills.
Miles per hour. All right, so for this one, it says give numeric values for each of the following. So the limit is, let's see, are we given the graph of f? Yeah, we're given the graph of f. So the limit as x approaches 6 of f.
What are you doing here?
So as x approaches 6 from the left and right, it is approaching the y value of 3. The next says the derivative at x equal 8. At x equal 8, so that's here. This is just linear. And so it looks like that if we increase by 1, we're going down 1. So this is a slope of -1. This says the integral from -2 to 2 of f of x dx. So from -2 to 2, I want the area under the curve. That would be this area plus this area. But the area underneath the curve is negative, and the area above the curve is positive. Those are actually rectangles that have equal area, so then the total area added up would be 0. F prime of -4, so at -4 we have a slope of 0. The limit as x approaches -6 from the right, so from the right-hand side we're approaching 1. This is the definition of derivative at x equal -7, so this is f prime of -7. So I can look there and I can see I have a linear portion of the graph So if I go over 1, I go down 1.5. So this is negative 1.5. This says the limit as x approaches 2 from the right, 2 from the right of the derivative. Okay, so as x approaches 2 from the right, I can see that we're going off to infinity, but it's not asking for the y value, it's asking for the slope. So the slope is a positive slope that's getting steeper and steeper, so it's approaching a positive infinite slope. The limit as x approaches 3 of f of x. So as x approaches 3, the left and right sides, they're both approaching the same y value of 0. F double prime of 6.3. So 6.3 is in here somewhere. This is a linear portion of the graph, so the second derivative is 0. Then it says identify all x values on the interval negative 8 to 8, where f is continuous but not differentiable. So I want to see where I have continuity, but I maybe have some sort of a dramatic change in the slope. So at negative 2, the left and right hand slopes are different. So negative 2 is one place. The other place where it's continuous but not differentiable is at 6, because the left and right hand slopes are different slopes. Okay. So that's all for